Hello, and welcome to Astronomy 100. In a previous segment, we were working our way through how the ancient Greeks were trying to come up with a way to understand the universe around them, and how they mistakenly believed that the Earth was not a moving body, no rotation to the Earth, no physical movement of the Earth through space, and how if you come to the conclusion that the Earth is not a moving body, then all of your other explanations of the universe have to include this stationary Earth, and one idea that's wrong will turn into many ideas that are wrong. And so this Earth-centered notion of the universe is called geocentric cosmology. And we were beginning to discuss how it was such a very long period of time that the ancient cultures of the Earth embraced the geocentric cosmology, and why would it last for so long when indeed it is so wrong. So we were looking at a particular timeline that describes how long geocentrism was able to last in the ancient world. And if you recall, it is an idea that's first introduced around the era of Aristotle, around the era of 350 BC. Aristotle describes how a system of epicyclic motion can explain the observed movement of the planets in the sky while keeping the Earth at the center. Some modifications were included with Ptolemy, but then following Ptolemy, it is essentially a period of nearly 1,000 years, or almost 1,500 years, that geocentrism is still in place. This takes us through the Dark Ages and the Middle Ages. And up until this era that you see here with all of these more familiar looking names, geocentrism was the assumption of the universe. So why? What we also started to include was how the assumptions of the universe were ones that fit in with the modern view of religion. And when a religion becomes a very dominant force of the ancient world following the fall of the Roman Empire, we find that the religious doctrines of Europe and of much of the world include the idea of geocentrism. It just seems to make sense to the scholars, the religious scholars of the ancient world, that if there is a creator, if God is going to create a universe and create people to occupy the universe and a place for those people, that the Earth would be the home of these people, but would also be in a very special location in the universe, at the center of the universe. So the belief that the Earth is not at the center of the universe would be one that runs against religious doctrine. And so there is no real challenges to the idea of geocentrism, because if you're challenging the idea of geocentrism, you're essentially challenging the ideas of the church. And in those days, that was an act of heresy. And many people would simply accept geocentrism as the way of the universe because the religion reinforces that idea. But what we find is, historically, there is a period of time where a lot of this begins to change. And this is the period of time that we refer to as the Renaissance. And the Renaissance is an era around the 15th century where we have a lot of changes occurring in the world, especially the world of Europe and of parts of Asia, where we have a change in the way that people do science, we have a change in the way that people think about art, a change in the way that people think about religion. This is an era of rediscovery. Many of the ideas of the ancient Greeks that had been buried over time are now being rediscovered. Architecture of the past is being unearthed when people dig up these ruins. And so it is an era of tremendous change, and again, the word Renaissance means rebirth, and it's an appropriate title for this era in our history. But what we find is in astronomy, there is also a renaissance, and it's a change in the way that we perceive the universe based on some new information or ideas that are resurrected from the past. Just like architecture of the past gets resurrected by being unearthed in some field that a farmer might be digging in, some of the ideas of the ancient world were also unearthed and were brought back to the forefront again. And so this era in astronomy history is what we call the astronomical revolution. And it is a revolution of thinking, it's a revolution of ideology, and in particular, we're going to focus on these four individuals. These are the four major players that were able to bring astronomy into at least a correct understanding of how the universe is perceived today. The first person we're going to discuss was, of course, a major individual that I'm sure you've heard of before, and this was Nicholas Copernicus. Now, Copernicus is somebody who embraced an idea called the heliocentric cosmology. And in the ancient world, the belief of the Earth being the center of all things was called geocentrism. And heliocentrism means sun-centered. It comes from the ancient Greek god of the sun, Helios, so heliocentric means sun-centered. And the philosophy is quite simple. The idea is that it is the belief that it is the sun that is the center of the solar system and universe, and that all planets, including the Earth, orbit around the sun. Now, although this heliocentric cosmology is a correct interpretation of our solar system, of course, the one problem is the assumption of the sun being the center of the universe. This is an idea that we today know is incorrect, but it is something that would take quite a long time for us to figure out where the sun is in our universe. So we're going to let them have that one, essentially. We're going to give them a pass. The belief that the sun is the center of our solar system was a major change. The problem is just because you make a change in your assumption, if you change from an Earth-centered to a sun-centered belief of the universe, it's not something that is just going to be readily accepted. There were 2,000 years of culture embracing the Earth-centered model, and it's not going to simply mean overnight, just because an alternative perspective is suggested, that the world is going to embrace this idea. So, as I mentioned, Copernicus is the first historical individual that will really push us down the road of finally embracing and accepting the heliocentric model. Nicholas Copernicus was a Polish astronomer. He was somebody who was college educated. He was somebody who was very good at mathematics. He was educated in the field of mathematics while he was in college. And he was born in 1473, lived to 1543. And he is often somebody who is referred to when we talk about the heliocentric model. But it should be noted that Copernicus never admitted or stated that he is the creator of the heliocentric model, but instead Copernicus talks about and refers to how the heliocentric or sun-centered model was something of the past that he learns about. While he's in college, he's educated about the ancient Greeks, something that had been done for many, many years in college. We call that Greek revivalism, where people in college are educated about Greek philosophy, Greek politics, Greek art, Greek architecture. And so when Copernicus was in college in Poland in the 15th century, he learned about all of these things. But what Copernicus also did was he educated himself a little bit further and beyond what you would have learned in college. In school, in college, he would be taught the geocentric model. This had been something that had been discussed for many, many years. It is an assumption that had been in place for, by this point, about 2,000 years. And so it would be no different for Copernicus. He's formally educated on the Earth-centered model. But on his own, he digs a little deeper. He reads about some more obscure ancient Greek philosophers. And in particular, one Greek philosopher that he learns about is Aristarchus. If you remember from a previous segment, Aristarchus is one of the very first Greek philosophers to suggest a sun-centered model. And the problem is suggesting a sun-centered model 2,200 years ago, it is not a time and a place for the world, the cultures of the world, to accept such a thing. But with Copernicus, there's been a lot that's happened since then, and Copernicus hears about and reads about this alternative sun-centered model, and he embraces the idea. To Copernicus, putting the sun at the center seems to make sense. It describes the universe in a way that is a little bit more closely matching what you see in the sky without having to do a lot of physical gymnastics to have epicycles and deference and make all of this work. So Copernicus, being the mathematician that he was, set out to try to prove or show the mathematics to support this sun-centered model. He's not the creator of the heliocentric model, but he's one that resurrects it from the past and is able to flesh out all the mathematics. So let me show you how he did that. Copernicus comes up with a particular way to show the sun-centered model that we're going to show here in this illustration on the left. This is an actual photograph of a diagram from a book that Copernicus ultimately has published, and we'll talk more about that in a moment. But in this diagram, what you can see is the sun is at the center, All of the language of this diagram is in Latin. So Sol is the Latin word for the sun. He's got Mercury, Venus, and then here is the Earth. The Latin word for Earth is Terra. So Mercury, Venus, Earth, and then Martis, which is Mars, Iovis, which is Jupiter. Jove is another word for Jupiter. So Iovis is Jupiter. And then he's got Saturn. And then the last thing in this diagram is what is called the Stellarum Fixarum Effara Immobilis, which is essentially Latin for the celestial sphere. So he believes that all stars of the universe are still attached to the celestial sphere, but you'll notice that he's got the sun at the center, he's got the Earth where it belongs, he's got the moon orbiting around the Earth, and essentially we have now a heliocentric model. So he's able to show all of this and show the way that it works from a heliocentric perspective. The one thing I want you to notice about this diagram, though, is he does not have any epicycles. So he's got the movement of all of these planets without employing the concept of epicyclic motion. So how does he do this? Because if you recall, when you go outside and you look at the actual movement of the planets themselves, the planets have a movement that is forwards and backwards and forwards. If you recall, we called this retrograde motion. So how is retrograde motion going to be explained if you don't have the use of epicycles or deference? So here's how he does it. To Copernicus, retrograde motion is an illusion. When you witness the movement of a planet forwards, backwards, and then forwards, in this case, this is the movement of Mars, demonstrating its retrograde motion in the sky, Copernicus says this is an illusion. What is actually happening is the sun is the center of our solar system, the Earth is a planet that is moving, Mars is also moving. Both Earth and Mars are moving in the same direction around the sun, but because the Earth moves faster, taking a shorter amount of time to go around the sun, what we have is a period of time where the Earth is going to catch up to, pass, and then get ahead of Mars in its orbit. So if you imagine a slower moving Mars and a faster moving Earth, what we see against the background stars is at first Mars will appear to go from west towards east. This was direct motion, if you recall. But then in the period of time where the Earth catches up to and passes Mars, the illusion is that Mars will momentarily, in this case for a few days, go backwards. And then as the Earth continues to get further ahead of Mars in its orbit, you'll notice that Mars will appear against the sky to resume its forwards motion. So the forwards, backwards, forwards motion is simply the effect of the Earth catching up to and passing Mars and then eventually getting ahead of it. Here's an animation that shows this concept, and it repeats, so you can see it more than once. But you'll notice that as it shows the Earth catching up to and passing Mars, the illusion is going to be that Mars is going forwards and then forwards against the background sky. And so what Copernicus is able to do is demonstrate that you can explain retrograde motion without having the Earth being the center of all things, an epicyclic motion combined with an Earth-centered universe, and this complicated set of circle upon circle movement to create the illusion of the sky. It's cleaner, it's more simplistic to have the sun at the center, make the Earth a planet like all the rest. The movement of the Earth creates the illusion of epicyclic motion, and everything is explainable in a much cleaner, simplistic model of heliocentrism. And so this is a major step forward in being able to explain what you see in the sky while also having a more simplified way of understanding the universe. The problem is it still requires the culture of the Earth, the scientists of the Earth, to accept that the Earth is a moving body. And if you accept that the Earth moves, then all of this makes sense. The problem is getting people to accept that the Earth is a moving body. And so what we will find is this major step forward needs to be followed by continued explanation to first prove that the Earth is a moving body, and then finally convince the people of the world that the heliocentric model is correct and that the ancient belief of geocentrism was a mistake of the past. In the next episode, in the next segment, we're going to talk about how this major step was made and how the astronomers of the day were able to finally figure out that it is truly a heliocentric universe. I hope you'll join me.